Hi everyone, welcome to this week's Entry Live. Today I'm very happy to announce that we have a new host with us. That is Chris Grice. Hi Chris Grice, how are you doing?
I'm doing well. How are you doing?
Good, good, thank you. So from now on, that Chris will be the third host, and he will uh bring us new idea and topic from the I think sales team, right? So which team do you work on?
Yeah. So I'm on the Avi COE sales team. I'm a solutions architect, a pre-sales role, but I mainly sort of deal with AKO related activities, and sort of general Kubernetes ingress networking, that type of thing. Uh,
Yeah,
yeah, happy to be here. Thank you.
thanks. It's great to have a different perspective of looking at the products that we're building every day.
Yep.
Because both Jay and I are engineers, so we are very very happy to have Chris to have Chris with us and
Happy
shares
to be here.
the customer's review of the products.
Yep.
Okay, hi Scott. Nice to see you here. And for all the audience, if you want to send comments to us, please remember to sign in your YouTube account so we can see your comments in the real time. And also, if you have any questions, feel free to ask in the comments, and we will answer that during the show. Okay. So today, Chris gonna share with us how to run AKO in OpenSwitch and vSphere, right?
Yeah, we're going to try to anyway. We're going to try and show sort of AKO in Tanzu TKGM. I'm going to look at a couple of different ways we can install it, and then if we have time, look at Openshift as well, and maybe also sort of talk through the public cloud scenarios as well, like EKS, AKS, that type of thing. Um,
Yeah,
we have time.
there are lots of great stuff here. So
Yes.
let's start it, and if we can finish it in one episode, we can have like a follow-up episode to
Yeah,
continue
yeah,
this
yeah, yeah.
topic.
Yeah, no worries.
Okay.
So I'll share my screen. Hey, Mitch. So this is the original Avi shirt. Badass. Beyond application delivery as a service.
Wow, that's great.
They're pretty cool. Pretty cool.
Yeah,
Mark.
yeah, right. Yeah, probably we should like have like a t-shirt for entry, like right.
Yeah, definitely.
Okay. Yeah,
Um,
please go ahead and share your screen.
can you see my screen?
Yeah, we can.
Awesome. Yeah. So what I'm going to do is sort of talk about TKGM first, and how sort of AKO is integrated into sort of TKGM. Look at kind of how the operator works, and then also kind of look at how we can also install sort of AKO via Helm as well, and sort of talk about how that looks. And the nice thing about this is that the Helm install is the sort of same install that we would do in any of the other public cloud environments, the any other vanilla Kubernetes, that type of thing as well. I'm also going to talk about no port local because obviously we're an Entrea show, and no port local is very specific to Entrea, and talk about why maybe we would use no port local and what kind of benefits it brings to Avi and Entrea as well. So yeah. Um,
Before you start, do you mind to zoom in a little bit? Because
yeah, sure.
can't
Is it
see
a
that
little
clearly.
small? Yeah. Let me remember. Text bigger. How's that? Is that too? Is that okay? Or
Yeah, yeah, it's better.
let me make it even bigger. Okay.
Yeah, it's good.
Awesome. Let me bring this up. So that's the bottom of my window. Yeah. So first of all, I thought what we would do is build a look at how we build a Tanzu cluster with a Geo operator.
Mm-hmm.
So it's actually very easy to do it. You just need you do it via YAML, and you can when you create your management cluster for TKGM, which I've already done, you can actually take that YAML file that you used to create it, and you can use that to create your guest clusters as well. So that's literally what I've done here. And if I kind of look at this, I'll call it test.yaml, which is pretty imaginative. But you can kind of see the options that we would kind of choose to enable, just to create a cluster. And what I'll do is I'll kick this cluster off, and we can. It will take 25 minutes or so, but just we can see how that looks. So from an AKO piece and Avi piece, the only pieces we need to do are enable the enable Avi. And additionally, we have an option to not enable a AKO operator AKO on the cluster. So what this means is in the I'm in the management cluster now. So if I do a kubectl get pods -a, give me a second. You can see that I actually have sort of a AKO operator pod, and then I also have a AKO pod in the management cluster. And so the operator pod is the piece that will deploy the AKO into your workload clusters. But if you have, there's a label that you can set on your clusters, your workload clusters, when you originally create them in this YAML file here, and I have it here, this AKO yes. And what this does is it tells the operator to install the AKO automatically into that workload cluster. But if you don't have this label, it won't install it. You can still use sort of the AKO for the the control plane API kind of thing, cluster API, but you don't have. It won't install the AKO operator. AKO operator AKO. And this can be a good thing because we have sort of, there are use cases where the AKO that's packaged with TKGM isn't the latest version. It follows pretty closely behind, but, for give an example, TKG 1.5.4 is ships with AKO 1.6.2. And the latest version of AKO is 1.7.1. So the upstream version of AKO is a little bit newer than the one that ships with TKG. So maybe that you want to use the upstream version instead of the operator version. And so this gives you that mechanism to do that. It allows you to sort of install your own version of AKO, basically.
So the available here is to select which workload cluster we want to install AKO, right?
Yeah, exactly.
Okay.
Yep. Another key piece is this Entree no port local piece. We'll set that to true. And so that's just going to turn no port local on within the Entree config map or the Entree config. I think in later versions, you don't actually have to do this, but I'm on 1.5.1, I think it is, and you just have to turn this on here. But the rest of it is kind of straightforward, TKG stuff. I'm going to set my cluster CIDR, cluster plan, do I want dev or prod? And obviously I can customize these things as well. If I was in production, I'd probably have a lot of this stuff turned on, but I'm obviously not in production. So I've turned it off, things, audit logging, LDAP, OIDC, identity providers, all of these type of things you would have on a production, but I don't need them. And then you're basically telling TKG sort of what your architecture is, what operating system you're going to use. So I'm using Photon, but you could use Ubuntu. You're giving it the service CIDR, the IP address family, IPv4. And this is TKGM on vSphere, so I'm going to use, I've got a bunch of vSphere information that I'm also going to pass in. But obviously TKG can work on Azure, AWS, etc. So if that was the case, you would have your, your IaaS service here as well. So, from my perspective, I have vSphere information, vSphere data center, vSphere data store folder, pretty typical, information that you might want to provide. So what happens is I have that YAML file, and then to create a cluster, I just do Tanzania cluster create. We're going to give it a name, so I could do Entree Live. And we'll just pass in that YAML file that we just created. And then you kick it off, and with any luck, in around 20 minutes or so, that will build your TKG cluster.
So here we are creating a workload cluster, right?
Correct. Yep.
Okay. Yep. So if I want to create like maybe a AWS cluster or Azure cluster, what does the test YAML doing?
Yeah. So
what does the test YAML looks like?
An example of that in front of me, but like basically the only real difference is these vSphere pieces you'll not have them. You will have your Azure pieces. I could probably do a dry run. I'm not sure if it would show it all. But yeah, that's really the difference. You would have the sort of AWS and Azure IaaS information. So you'd have your AWS account, which VPC, do you want to create a new VPC, that type of thing. And that would be the information there. But the setup is pretty similar. The other nice thing about this is that you can do it through a UI as well. So if you want to do that initial, rather than sort of deal with YAML straight away, if you want to do your initial configuration via the UI, you can do that as well. So they offer you that as well.
Yeah. So the overall process is like very similar, just like some parameters are.
Yeah, pretty much.
Okay.
Yeah.
Okay,
And
that's good.
yeah. And it basically goes out to AWS or Azure and pretty much does the same thing. It will build you the management cluster first, and then you interact with that management cluster to build workload clusters.
Does it mean that if I want to create an AWS cluster for the workload cluster, the management cluster should be AWS or vSphere? Is there any restrictions here?
I believe you have to have it if your management plane has to be in the same sort of IaaS provider. So you couldn't do a vCenter management plane and then an AWS workload cluster. You would have your management cluster up in AWS and a management cluster in vSphere as well, if that makes sense.
Okay. Yeah, that makes sense.
And let me make this one bigger. So I just so that other window there is going to take a little while to that other cluster is going to probably take 20 or so minutes to build. So I'm going to go to one. Here's one we prepared earlier, and just talk about sort of what the. We should start seeing it here. What did I call it? No, I lost. There it is. So you can actually see here. So I have Avi running the control plane, the cluster API for my workload clusters. And you can see that one that we just built is already up. And now I'm I'm load balancing that through Avi.
Yeah, there are some like interesting questions in the comments. Probably we can like see if we know the answer. So so this question, how to change the image of Ako operator as it's running as an add-on operator?
Yeah, I'm not not sure that you can actually. I think it ships with what it ships with. So yeah, you can. What is yeah, you're using TKGM 1.42 and the AKO version doesn't support a live feature. So this is a great use case where you might want to do a Helm install. So depending on whether it could be tricky if it's an existing cluster and you have the operator already installed, but there are ways to kind of remove it. And you can Helm install the AKO. So the thing to remember as well is that there's two pieces to this. There's the AKO operator itself, and then there's AKO. So AKO itself has the alias feature that you're looking for, and the operator is the piece that just manages that. The operator manages the AKOs that it's installed, but you can install via Helm separately and take advantage of those newer features.
Yeah, basically, if my understanding is correct, that AKO operator is another way to install AKO in a cluster, right? Of course, it has like other features to make the installation more fancier, but like it's still like a best. So the basic functionality of AKO operator is still to install AKO. So and the AKO, the image version of the AKO and AKO operator is consistent with the Tanzu version. So like
Yeah.
so
Um,
probably it's hard to
so
install AKO operator to a different version than the Tanzu supported, right?
yeah, in fact, I don't think you can. So you couldn't have, you couldn't run, how can we say it? You couldn't run TKG 1.4 and then have 1.54 operator. I don't think you can do that. So the only way to really upgrade your AKO version is to sort of Helm install it, which is supported. It is supported. It's just not as automated as a traditional, as your AKO operator is. And I'm actually going to sort of show the differences actually. So what I have is, let me, so I've got a couple of clusters here. And what I'll do is I'll jump into actually, first of all, I'll start with the management cluster. Because how you actually configure the AK, once you've built your management cluster, you've deployed a workload cluster like we just did. And initially, that's going to come up, the AKO is going to come up in sort of a layer 4 only mode. And so you won't be able to do ingress with it to begin with, and you won't be able to take advantage of some of the, the more advanced features. But how we can configure those pieces is via an AKO deployment config that actually lives on the management cluster. And how that works is if I do like a get ADC, and just take a second, you can see here I've actually got 3 ADCs, but by default it ships with 2, which is the install AKO for all and install AKO for management cluster. So the install AKO for management cluster is pretty self-explanatory. It's actually configuring. I'm in the management cluster now. So it's actually configuring the AKO that's running in the management cluster. And this is the AKO that's building all my control plane virtual services here. So all of these sort of control plane virtual services, they're built by the AKO in the management cluster. And that AKO is configured via this install AKO for management cluster. Now, when I deploy my new, workload cluster, and say, for example, I want to turn on ingress, or I want to turn on some advanced feature that I need. I've got 2 here. One of them is turning on ingress. One of them is turning on no port local. But what I actually have to do, so if I have a look at this, install AKO for all. Sorry. I'm on the loaner laptop, so sometimes it doesn't act right. But you can see under the spec here that I have a bunch of sort of configuration items. And what I can do is how these work is there is a cluster selector. And what the cluster selector does is you can label the cluster basically from the management cluster. And then that label will match the ADC CAD. And basically what we'll do is we'll push this configuration down to the AKOs in that workload cluster. So that's kind of how we can configure the various different ADCs. This one's matching off AKO yes, which was, if you remember back to when we built the cluster, we had that label created. But what we'll see is when I do, I've got a no port local port example, and that's matching off a different label. So that gives you kind of really fine granularity into what how you can configure the various different AKOs on each workload cluster. So it's pretty useful. But generally, I'm kind of just passing you. There's a few more options that I don't have here, but I'm giving it the CNI plugin. In this case, we're using Entrea. these are configuration options for AKO to work. So I'll talk about this in a minute, but for our cluster, to work with cluster IP, we have to sort of either do no port local or use static routing. In this case, I'm doing no port, so I've turned off the static route sync. EVH is Enhanced Virtual Services, Advanced Virtual Hosting, sorry. By default, how we build ingress, and I'll look at this in a minute too, is we use an SNI-based model. But we do have an EVH option as well, which is a little different, a little bit more feature-rich. But it's newer, so it's a little beta-ish, but it's another option that we have. Some ingress options, so I can say I'm the default ingress controller. When I say this, it means that I don't have to use ingress class. If this is turned off, then I have to use ingress class and use the AVLB ingress class within my ingress definition. To enable that particular ingress to use AVI. And there's just a couple of other options here. Node network list, that tells AKO what network my nodes are on. And this is useful for that static routing piece. Service type is a little bit self-explanatory. It's basically saying, are my services that I'm providing ingress for, are they no port services and cluster IP, or we can also do no port local here as well. Shard VS size is pretty interesting too, because we're using a sort of parent-child SNI based relationship for our ingress. We can use, so we'll have multiple host-based routes on sharing one IP address basically, and the parent VS, which owns the IP address, we can actually sort of change how many of those we can use. So in this instance, we're doing small, but you can do medium and large or dedicated. Small will build 1, medium will build 4, and then large will build 8, and then dedicated will actually do an IP address per ingress. So this is a pretty cool way to sort of save IP address space, that type of thing. And it's pretty cool. We also have layer 4 features, so we do support gateway API at a layer 4 level, so that's pretty interesting, and we'll enable that via the services API, I believe it is, and this will turn on gateway API at a layer 4 level, so we can don't take advantage of that feature set. We can, you know how gateway API works with sort of gateway class, and we can kind of do like layer route-based services for layer 4 services. And this is, we can actually sort of put layer 4 services behind just one IP here as well. So we could have multiple sort of service load balancers behind one IP, but they would have different ports on the front end. So have a few customers using this for IP conservation processes. So each sort of service type load balancer doesn't take its own IP. So it's quite useful. And lastly, we're just sort of declaring the service engine group. And you're basically telling AKO which service engine group to use on the AVI controller. And there could be many reasons. You could have different service engine groups. You could have different service engine groups because you want to size your service engines differently, or there's various different reasons why you might want to have different service engine groups. But the idea being is that this is pretty comprehensive way how to configure AKO when you're using the AKO operator. And yeah, that's pretty much the ADC. So as I was saying, you label it, and that pushes that config down to the label clusters. So if I sort of jump into cluster 2, and I look at the AKO config map in that cluster, you'll see that that matches basically what we pushed down. So you can see default group, the node network list, the VIP network list, the small, the fact I'm using node port, etc. That's basically that AKO ADC is pushing the config down, and then configuring AVI over here as well. Yeah, so that's really the operator. What I was going to do yet next is just do a Helm install, which is probably something you'd see on any cluster that isn't a Tanzu cluster. I'm going to do it on a Tanzu cluster, but if it was Openshift, EKS, AKS, GKE, this would be the way that you would install AKO. Was there a question on? I thought.
Yeah, there's an interesting question asking that any reason to use AKO on TKG in AWS or Azure?
Yeah, so that's actually a good question. Yeah, so the reason you would for ingress specifically, today I believe you'd have to use you'd have to bring your own ingress controller, whether that be sort of Nginx, console, etc., or you'd have to use the default, I think it's application gateway in Azure and the layer 7 load balancer in AWS. And one of the interesting things about using the native load balancers is that they get very expensive at scale. So Avi can actually be cheaper if you're sort of looking at like really large clusters and you need a lot of sort of layer 7 load balancing in the public cloud is pretty expensive. It adds up pretty quickly. So that's one reason. Another good reason is that we tend to have better feature sets than sort of the public cloud load balancers. And then when you want to sort of compare us versus sort of a console deployment, that question is, console's a pretty good ingress, and AKO is a pretty good ingress too. But that kind of would come down to sort of the added value that Avi brings to the table in many ways, just analytics logging, those type of things. But yeah, the public cloud is a very good use case for us. Not to sort of digress to Avi itself, but we have a lot of customers in the public cloud that have, because we're a really good fit for public cloud because we can, we're an enterprise grade load balancer, but we have all the same sort of feature set that you used to in the public cloud, whether that be sort of, elastic scalability and all that type of thing. So we lend ourselves very well there, and then the AKO ingress controller ties into all of that. So it's a pretty good story.
Yeah, and right now the AKO on the in the AWS or Azure is still like you need to use the Helm to install that.
Yes.
Maybe in the future release
It will be the operator. Yeah.
Yeah, we will like make the AKO operator available on not only vSphere but also on AWS or Azure, so you can do that. So you can use the consistent ways to install AKO in all different kind of clusters.
Yep. Yeah, and there's actually an ongoing discussion about that. I was talking to a few colleagues the other day on the MapVU side about how we will integrate because it's quite difficult to sort of disassociate the cluster API piece from the ELB. That's quite built in. So I'm not sure that the first iteration of that will have AKO running cluster API like we do on-prem. But for regular server-side load balancer and ingress, we will definitely take that piece. And I think that will happen relatively soon. In the new release. I see a question as well. Can you let us know, how do I pop the question up? The bottom.
I can do that.
Thank you. Can you please let us know configuration change required in ABC if we configure an AKO in cluster IP mode? Sure. So to do that, let me go back to my management cluster and let me look at the CRD again. Actually, what we'll do is is this a good example? Yeah, it is. Really, all you need to do is change the service type to cluster IP and make sure that the disable static route flag is set to false. But then everything else would be the same as sort of no port. But that should do it. So we need this disable static route flag set to false because of the way that Avi interacts with clusters when they're set to cluster IP. And then you just need to change the service type to cluster IP. and that should do it. Another option is obviously to use no port local as well, because there are, when you look at how Avi works in cluster IP mode, we use, because we're kind of different to a lot of ingress controllers insofar that our ingress point, AKO itself lives in the cluster, it lives as a pod, we've just seen that. AKO talks to sort of the Avi controller, which talks to the service engines. And the service engines are where your actual ingress endpoint is, your service type load balancer pieces. And to get, oftentimes, right, your pod networks are, very the same on all of your clusters. Like, for example, when I ran through that sort of TKG, created my cluster earlier, I didn't change the pod siders spec, the pod siders. So, it could be quite possible that I have multiple clusters and the pod networks are the same network. And so if I want to run cluster IP services in that endpoint, because my pool members behind my ingress are the actual pod IPs, I need to route into the cluster to get to the pods. So what happens is I'll typically deploy my service engines layer 2 adjacent to the Kubernetes nodes. And AKO, what it'll do is it'll go out there and it'll build routes and say, hey, this pod network is via this node. But then the problem becomes, if I have that same network on multiple Kubernetes clusters, I could feasibly have those duplicate routes, right? Because I could have, say, 10/8 via cluster 1, 10/8 via cluster 2. So how we get around that is we use route labels. And currently the route labels apply to a service engine group. And so you would have a service engine group per cluster, and then you can support that the same overlay routing pod networks on different clusters. And that's also kind of where no port local comes in, because one of the, and I'll see if I can draw this out, it might be a little bit easier to visualize. But say I have cluster 1 over here, and then I have sort of cluster 2 over here. I'll just put this in there. And for example, and I'm going to be very generic here, but say my pod network was 10.08.10.0.0, we'll just say /8. And this one was also 10.0.0/8. Can't type. When the service engines get deployed, and imagine if I'm, and I'll change this to the orange, but imagine, wrong one, if my service engine is sat out here, and this is where my ingress is. Cool. The service engine, what AKO does, and AKO is also sat here. What AKO does is it will tell the Avi controller, it'll say, hey, to get to, well, let me break this, make this bigger actually. So we've got 2 clusters, and then I'm just going to have 2 nodes. So node 1 and node 2, and say the node network, for example, would be, this would be like a routable network within the environment. And say that's sort of 192.168.0.0/24. My Avi service engine is, .10 on that network, and then my Kubernetes nodes are .2 and .3. Because the cluster cider is, say it's 10.0/8, so say I have 10.0/24 here and 10.0.0.1/24. AKO is going to reach out to the Avi controller, reach out to the service engine, and plumb some routes by basically saying, to get to this network, go via 192.168.0.2 or 192.168.0.3. So that works well in one cluster. But if I have sort of the repeated thing over here, and say this is my second cluster, this is .3, and this is .4, and my overlay network is the same, right? Now I've got a problem because I have routes to 10.0.0, .1 via this Kubernetes cluster, they also have that same route by this cluster as well. So if we do not use no port local, what would happen is I would have a service engine group for this cluster, and then I'd have a service engine group for this cluster. And then service engines can have different route tables within the same network. So that's how I sort of get past that problem of the duplicate networks. But one disadvantage of this is that it requires, say I have lots of small clusters, say I have 15 small clusters, I'm going to have 15 service engine groups, which ends up being sort of 15, 30 service engine cores, which can be quite expensive for customers. Their Kubernetes footprint might not even be that big. So that's why no port local was introduced, because it really sort of solves this problem. It enables us to use cluster IP services, so we don't have to use no port services. But what it actually does is it does a DNAT IP tables, and what it'll do is it'll DNAT the kind of the pool endpoints. So within a cluster, when we have a cluster IP service, the pool members are the actual pods. So what will happen is with no port local and cluster IP, the pool members become that DNAT, and that DNAT is made up of the node address, so very much the same as a no port service, but then it will have a unique port which is tied directly to that pod. So that gives us an advantage over sort of the regular node port, because with regular node port, although you can do some kind of source affinity, you can't really, if there's multiple pods in or replica sets in one cluster, you can't efficiently load balance to all of them. kubeproxy won't do that efficiently. So we offer advantages there. And the bigger one is that because we're exposing the pod, we're exposing a cluster IP service, the endpoints behind that cluster IP service are on a node port, which is a unique port. We don't need to have this sort of duplicate service engine arrangement, and that can save, the customer cores and money. So it's a pretty cool feature that's helps us, and that's in upstream on Trail as well. I believe that was all. I think it's in on Trail 1.2.3 and above. That's enabled by default. So useful tool if in that when you're running that. And I actually have a TKG cluster running no port local, so you can kind of see what that looks like. If I can remember which one it is. Yeah, this one here, no port. So you can see here I only have the one node. These are dev clusters. So I have one node, but I have 4 replicas. I have a pod running, there's 4 replicas. And so if this was a no port service, that pod with 4 replicas would have, it would just have one node port, right? So it'd be sort of 10.206, 114.92, :, 32000, whatever the node port is. But I've got 4 pods, and so normally what I would be doing in a no port scenario is I would then be relying on kubeproxy to actually do the load balancing, not Avi or AKO. And so with no port local, because I'm tying a particular port, in this case it's in the 61,000 range, to a specific pod, I have Avi as the load balancer, and so I'm able to sort of choose. I can choose all the algorithms Avi has available, and it's a much better way of load balancing, and you're not relying on kubeproxy. And it responds quite well too. So if I come back to my CLI, and I go back to CTX, and I go back into, which one is it? This one here, and I edit my deployment. And for example, say I want to spin up, or actually spin down, because my CPU. Say I want to, just change the replicas to 2 in my deployment. Avi will actually respond to that. AKO will respond to that pretty rapidly. Well, it should do anyway. Yeah, so my files have gone down. This time, it would have done it. See, now it's gone down to 2. So, you know, it reacts to sort of spinning up, scaling out pretty quickly. So that's quite useful. And you can see that, let's say, if that's big enough, you can see there's a sort of individual port. So that's no port local. There's no more questions, right? I think we got. Did we get all the questions? I think so.
I don't think we have new questions, but it's really cool to see the node protocol in a real time demo.
Cool. Yeah, yeah, I like it. It's pretty neat.
Yeah, it's a really cool feature.
Yeah, and that's unique to Entreya as well. So you know you have to run Entreya to do that. What I'm going to do now is just show sort of a Helm install of AKO. So you know we talked about AKO as an operator install. So we'll have a quick look at how it looks from a Helm install. So I'm in. Let me just make sure I've deleted it. Let me just delete it. So I already had it installed. I'm just going to delete the current one. And make sure it's gone. Sure it has. So interesting as well. I actually have AMKO installed in this cluster, which is the GSLB feature. Which if we get time, I'll talk about that later. But AMKO is a multi-cluster Kubernetes operator, and this enables you to do sort of active-active across multiple clusters. So you could do active-active across TKG, Openshift, vanilla Kubernetes, and even the public cloud in some use cases. And the public cloud use case is going to be, I think it's in the next release of AMKO, going to be sort of strengthened quite considerably. So it'd be quite cool that you could have applications running in the public cloud and on-prem and sort of GSLB load balance between them. You know, you can do sort of weighting and things like that. And it's useful because it's almost a service mesh use case, right? Multi-cloud, GSLB, that's almost a service mesh use case. But, you know, what we often see is that not everybody is ready for service mesh, you know, and if you're not ready for it, this is, and you just want an ingress controller and you want to do multi-site deployments or active standby deployments, this is a very good way to do that without having the overhead of service mesh. It doesn't do sort of all of the cool features that service mesh does, like MTLS and you know, some of the canary stuff, etc. But it is pretty useful if you want to sort of extend your ingresses, your applications across multi-cloud or on-prem, that type of thing. So I'm going to now install Avi via Helm, and we do that, you know, by passing in a Helm chart. And you'll probably notice that the Helm chart looks very, very similar to the ADC. I mean, it's pretty much the, you know, the fields are very much the same. There's probably a few more in here, but the ADC is basically this and a CRD, you know, like a CRD basically.
Yeah, I remember we expose all the parameters here to the ADC.
Yeah, exactly. You know, and the only ones that you're missing on the latest version on TKG are the very latest features of AKO. So here I'm actually doing a 1.64 install, so it's pretty much the same as the ADC. But the thing to note here is just that this would be the same in the public cloud, on-prem, you name it. This OpenShift, you would install it the same way. And there are a lot of fields. There's a lot of customizable options here, but the only ones you really need is a cluster name, which is kind of a unique identifier for the Avid controller to sort of label that cluster. So, have that as a unique name. It could be anything. It doesn't have to be the actual name of the cluster, but, why not? You know what I mean? That makes sense to make it the name of the cluster, but it could just be Chris if you wanted it to be that, or, it doesn't really matter. But I went too far. The other pieces are, so CNI plugin is used on certain CNIs. If you want to do Entrea and no port local, then we have to reference the CNI plugin. We just type in Entrea. We also need it for Calico and Openshift. And that's basically just to tell AKO how to find the pod sizes, basically. Like with Calico, you could be using a block affinity CID, or you could be using, there's various different ways that Calico, for example, defines pod networks, and they may not be listed in the pod siders. So there's just different ways that we need to make AKO aware that we're using said CNI, just so it can find the pod siders and work like that. We support a lot of CNIs, actually. I mean, it's only Weave I can think off the top of my head. Someone else can probably think of other ones, but Weave we don't support, but pretty much all the rest of them we do. Even definitely Entrea. So we support a lot of CNIs, and that's really the other interesting pieces are. We do support flannel. Just looking at that question there, we do definitely support flannel. Entrea is obviously the best one, seeing as we're on the Entrea Live podcast. But if you do want to use flannel, you can. But do use Entrea. And what else was I going to say? So Cilium is an interesting one. We actually have a customer running Cilium that does work with AKO, but we're not. It's going to be officially supported very soon, but it isn't yet. But there's no reason it wouldn't be. We actually had a conversation with Isovalent very recently about support for Cilium, and there's no reason we won't be able to do it. And as I say, we're actually cocking a customer with it as we speak. So just moving on, the other interesting fields are the VIP network. So this is the network where you want to put your virtual services. So in this instance, I've got them all on this 10.225.9.9. It's 8.0/22. So that's this network here. I want to be the default ingress controller because it's I want to be that. But if you have a use case where perhaps you have an existing ingress and you're doing the migration, something of that nature, or you can set this to false and then just use ingress class to define ingresses for Avi. I think I mentioned that already. Service type, shard size, this all works the same as it does in the ADC. And then down here, you're saying that service engine group name, the controller version, which cloud I'm using, the controller host. This could be FQDN or IP address, which tenant I want that cluster to go into. So for example, I can have different clusters and different tenants. And this is pretty cool too, because I can, this gives me the option to, because we have great RBAC, we can give a one particular, say you have a DevOps group that own cluster 1 or DevOps group own cluster 2, you can give them access to their own tenant and they can knock themselves out and troubleshoot and things of that nature. So it's pretty neat. And then finally, we have the username and password. You can use an auth token as well, so you don't have to have the password in your values file. So say this, you're storing this up at GitHub for CI/CD purposes or something like that. You don't have to have your password in there. You could, we can generate an auth token, and AKO can use that auth token to authenticate to the controller. So once you've installed, you've created your Helm chart, you can install it, and so you basically just add the repo. So it's AKO minus AKO. The repo, you can see the current version is 171. I'm actually going to put in 164. But very easy to do, just like any other Helm chart. Helm install AKO. Generate name. I'm going to give it the version 1.64 minus f values.yaml. And I've already got the Avi system namespace created, but we'll put it in its own namespace as well. Oh, I did it wrong.
Yeah, 1.6.4.
Yeah, 1.64 is not the right version for sure. So and that's really it. It's pretty easy to install. Pretty easy. So what I'll do usually when I first installed it is obviously get pods in the namespace, and we can see it's running. Oftentimes it'll crash loop pretty quickly if there's a failure.
Yeah.
And yeah.
Yeah, so if you install the AKO like this, it should be if you have several workload clusters, you should do that one by one in each cluster,
Yes,
right?
yes, you should. Yeah.
Yeah, but with the help of AKO operator, it will as long as the workload cluster match the label selector, the AKO will be installed automatically into the workload cluster.
Yep, exactly. Yeah. And that's obviously the great advantage of the operator is that it'll do it all for you. And you can use sort of other automation tools to install it via Helm, but there's always that chance of fat fingering something or something of that nature, which the operator kind of takes that away.
Yeah, and also if you use the AKO operator to install the AKO, in case someone that changed the configuration of one of the AKO in one workload cluster, the AKO operator will change the misconfiguration back because the AKO operator is watch the configuration of AKO in the workload cluster.
Yep. And that's actually a great point. That's a really good point because you would think that you could edit the config, like for example here in my cluster, Helm install cluster, I can edit the config map, right, which is all of those fields that we just looked at. And with a Helm installed AKO, I can change any one of these, reboot AKO, and they'll take they'll take effect. But if I'm using the operator, I could change this to my heart's content, and the AKO operator is going to change it right back. And so right. We need that ADC to push that configuration down.
Yeah, the add-on controller, if I remember it correct, it should be reconciled every 5 minutes.
Yeah, and it could be faster than that because I've actually seen it happen very quickly. You can be sneaky and you can pause it, and there's ways to pause the controller, and you can go in and change some stuff and then unpause it.
Yeah, right.
You can be a bit sneaky with it, but best bet is to do the ADC, and
Yeah. Probably the ADC. I mean, if the AKO configuration is managed in the workload cluster is managed by AKO operator, probably it won't take 5 minutes because it doesn't leverage the add-on controller to do the reconciliation, right? I think the AKO operator itself watch the resources, and as long as it's inconsistent, it will change it back.
Yep, and it happens pretty quickly.
Right. Probably only 5 minutes.
Yeah, because changing anything here, it puts it back right away. So it's it used to be a little bit tricky because when the AKO didn't support all the latest features, you had to be a little devious to get things to work because you could always go in and edit the ADC and you could edit the CRD that backs the ADC, and you could add in the AKO features there, pause the controller. And then it was one way we got no port local to work on TKG 1.3, I think it was. No, 1.4 is you could pause the controller, go edit the CRD, add the fields in that you needed, and then unpause it, and then it would actually push it down. I don't think that was supported, but like in PFCs and things like that, to get people used to Notebook Local, that was an option.
Yeah, I think the AKO operator starts supported in Tanzu 1.3, right?
Yeah.
But I don't really remember that. It's because add-on manager is not introduced in 1.3. So probably if you are using Tanzu 1.3, there's something different than what we are showing right now, right?
Yeah, it was. Yeah, I'm not sure what the differences are, but it is pretty different. It is pretty different. There's a lot of things you had to do to get various things working.
Yeah. So what we're showing here is more like 1.4 and 1.5.
Yeah.
Yeah.
I mean, obviously 154 dropped today, but yesterday I think it was.
Mm-hmm.
But yeah, I mean that's the config map, and you can change that. And sort of the last thing I'll do, if the logs are pretty good. Let me just. So if you did have an issue, the logs are going to tell you what the issue is. And for example, if it can't communicate with the controller, it's just going to error and crash loop. And it's like any kind of pod. There's various levels of debug. You can have debug, info, warning, and error, obviously, and it's very granular. It'll tell you, exactly what is wrong. The only kind of problem is sometimes it's too verbose, and narrowing in on the actual problem, takes some good grepping. But generally, it'll tell you exactly why it can't do what it's trying to do. And if it's an error where it's crash looping, it'll tell you what the error is, whether that be your config map is incorrect or something like that. It'll tell you pretty easily what's up. And then I think I already had an ingress defined. Let me see if I did. Yeah, I did. I actually have two, and you can see sort of. I think this. Let me see which one did. Hopefully one did. Yeah, this is it here. And like going back to sort of that parent-child relationship. So this is the parent SNI virtual service, and I can click on this, and I can disregard this. This is just another one that's broken right now. If I click on the virtual service configuration, you can see it's an SNI-based virtual service, and it's the parent. So what will happen is, as that communication comes in, DNS, it could be Avi, it could be any other DNS provider, will point the, in this case, sort of bit1.site1.avi.com to the IP address of this virtual service. And then this virtual service is going to look at the SNI header, and it's going to see the host name, and then it's going to pass the host name onto the child virtual service, which is this one here. And then that child virtual service does the SSL offloading and passes it back to the pod. Cool. I know we've only got 2 minutes left, so I don't know if I talk too much or talk, but
yeah, I think it's like it's a great pace because we want like if you don't know much about AKO and LV, after you watch our episode, I hope that you can try it after you you can really try that out in your own cluster. So it's like a great introduction of how to run these things, so people can try out after they watch this.
Yes, please do, and please reach out if you have any questions. I'm happy to help.
Yeah, and we only have 1 minute left. So is there any other questions from our audience? It seems like people are understanding this one really great.
Okay.
And yeah, we can talk about it if we want to do like a follow-up episode of running this on different kind of clusters.
Yeah, it'd be cool to do like a multi-cloud one for sure. Yeah.
Okay, that's really great. Thanks, Chris, for telling us this, and I learned a lot from this episode.
Oh, good.
Okay. Okay, guys, see you next Wednesday.
Bye. Bye.
Bye.